Welcome back to Aurora Tech Channel. Today, I'm going to test out the AnyCubic Kobra 2, which is a fast printing machine that claims to be able to print at 250 millimeters per second, and it runs Marlin firmware instead of Klipper. Generally, we would expect a fast printing printer to run Klipper because when using input shaper, it can compensate for the vibration and movement caused by the speed of the motion system. Besides input shaper, if a 3D printer needs to print quickly, the kinematics, motion system, extruder, hot end, and cooling all play important roles. So let's take a look at what this AnyCubic Kobra 2 comes with. For the kinematics, it's a bed slinger with a strong Y-stepper motor, which is a NEMA 17 48mm motor. While a normal bed slinger would probably use a NEMA 17 34mm motor, this 48mm motor should be able to provide more torque and power to move the bed faster. For the motion system, it uses steel wheels on the X and Y axis, similar to those on the X-Tool laser engravers. So, when moving at higher speeds, it won't wear out like regular rubber or palm wheels. For the Z-axis, it just uses regular rubber wheels. The extruder is a 4:1 gear ratio direct drive. The heatsink is similar to the one used on the Bamboo Lab with the Volcano-style heated block. For the cooling system, it uses a 5020 blower. When I visited the cooling fan manufacturer's website, the datasheet shows that the airflow of this 5020 blower is 6 CFM, which is almost double the 3.23 CFM of a 5015 blower. Moving on to the other features. It has a dual Z-axis, but it doesn't use dual motors and instead uses a timing belt and bearings to synchronize both lead screws. It has a silicone block at the rear of the print bed, which is used to wipe the nozzle, and there's a sensor next to it, similar to those tool height sensors on an auto tool changer CNC machine, which sets the Z offset automatically. There are no manual leveling knobs under the bed, so it relies solely on the inductive auto bed leveling. It also comes with some features you would expect from a typical mid-range 3D printer, like a 4.3-inch color touchscreen, a 32-bit board, silent separate drivers, a textured PEI spring steel sheet, belt tensioners on both the X and Y axis, a filament sensor, clean cable management using a single ribbon cable, and a slightly more powerful 400-watt PSU. The price of this printer is around $280, so for this price, the hardware looks really good. I would like to thank AnyCubic for sending me this machine to review, and with that, let's get started. The packaging of this printer is similar to other machines, as it uses laser cut foam to safeguard all the components. Inside, you'll find the base, the gantry, a 4.3-inch touchscreen, a print head, a filament holder, as well as various tools and a power cable. Assembling this printer is simple. This should take about 10 to 15 minutes. Let's turn it on and start with auto leveling. First, it will home the printer and then preheat the bed and nozzle. Next, it moves the nozzle to the silicone block for cleaning. Then, it moves to the other sensor next to the silicone block for tool head height setting, so we no longer need to use a piece of paper to manually set the Z offset. After that, it starts a 5x5 auto bed leveling. It's interesting that the cooling fan turns on and off when the tool head moves up and down, as it kind of looks like the print head is breathing while working out. Okay, let's check the Z offset. It's automatically set to -1.9 millimeters. You don't normally need to touch the module calibration button unless you find that the tool head is not aligning correctly with the tool head sensor. In that case, you can adjust the X and Y position here, but since my tool head position is correct, I will just leave it. Next, I will preheat the printer and load some filament. Okay. It seems everything's working fine, and we can start our first print. I will start with the only Gcode file on the SD card, which is a 30-minute Benchy. Before the print starts, it homes the front left and the back left corner. I'm not sure what the advantage of homing these two positions instead of the center of the bed is, but I'll just let it start and see. It looks like it starts printing quickly right from the first layer, around 40 to 50 millimeters per second, compared to the usual 25 to 30 millimeters per second speed for the first layer. Okay, the first layer is done. In the second layer, it speeds up a little bit more, but the cooling fan still hasn't kicked in, so I'm assuming the slicer has set the second layer to print at a slower speed. When the third layer starts, the fan finally kicks in, and it looks like this is the actual speed of the print. The nozzle temperature is set to just 185 degrees Celsius, but surprisingly, I didn't see any under-extrusion even when printing at this high speed. The print finished in 30 minutes. The surface is clean, with not much ringing or ghosting, but it doesn't look like it was printed at a 0.2mm layer height. The cooling is also good, except for this corner where the filament dripped a bit. The front of the Benchy cooled pretty well, and the layer lines are all clean. Then, I will set up this printer on my computer. It comes with a profile for Prusa slicer. Just import it and you will get a PLA profile. Since there is only one profile, it prints at 150 millimeters per second with a 2500 to 3000 acceleration, so I will just use it as a reference to set up a few profiles for different print speeds and filament. Okay, I have now created profiles for PLA, PETG, ABS, TPU, and Nylon, which are the filament types I'm going to test. I also created print settings ranging from 50 to 250 millimeters per second in speed and from 0.2 and 0.28 millimeters in layer height. I will share all of these under the video description. First, I will use the 0.28mm and 250 millimeters per second PLA profile to reprint the Benchy and see if I can get the same result. The estimated print time is 31 minutes, which is pretty close to the factory one. It actually finished in 32 minutes, with slightly less stringing than the factory Gcode one. Besides that, they are very similar. Since they were both printed at a 0.28mm layer height, I will print a normal one at a 0.2mm layer height. The estimated time is 40 minutes. The 0.2mm layer one looks much better than the 0.28mm one. I can no longer see the filament dripping in this area. Personally, I still prefer the 0.2mm one, and I am willing to spend an extra 10 minutes for it. Up next, I will print a more challenging model, a honeycomb drawer tower. Using the Prusa slicer with the MK3S Plus, it will take 9.5 hours. However, with this Kobra 2 printing at 250 millimeters per second, the estimated print time is 4 hours and 8 minutes. When you look at it on its own, you could say it was printed pretty well. But when you compare it to the one printed by the Prusa in 9.5 hours, the surface on the Prusa one is better. But the extruder of this AnyCubic handles the retraction better, as there are fewer honeycomb pattern breaks and much less stringing compared to the Prusa one. Next, we will print some drawers for this tower. With the Prusa slicer and the Prusa MK3S Plus, it takes 6.5 hours, whereas the Kobra 2 takes 2 hours and 20 minutes. The extruder can barely keep up with the 250 mm per second speed, as this model has longer lines, so the print head accelerates faster than it did when printing a small object like a Benchy. The ringing and ghosting are quite obvious, but for parts like this drawer tower, I can accept these trade-offs if I can save 2/3 of the total printing time and get a slightly rough surface that is fully functional. Then, I will use Marlin Sparkle PLA to print this Jeep. First, I will print at the top speed of 250 mm per second with the same 2.5 to 3K acceleration, which will take 3 hours and 7 minutes. The print ended up finishing in 3 hours and 5 minutes. The result still looks pretty nice, as I can't see any issues with it yet, but let's use Cura to create a 50 mm per second profile with 25 mm per second for the walls and first layer. I want to see the difference between the slowest and the highest printing speed using the same printer and filament. This will take 8 hours and 46 minutes. And the print actually finished in 8 hours and 25 minutes. When compared to the slow one, I can see some ghosting and ringing on the fast model, especially on the engine cover. From the side, since the two slicers are printing lines in different directions, the slow print looks a little bit better. At the top, they look very similar. At the front, the details on the slow print are still better, especially when you look at the pattern on the tires. But overall, the 3-hour one is not far from the 8.5-hour one. In this case, I would definitely rather just save 5.5 hours. Next, I will try some PETG. As PETG can't be printed as quickly as PLA, I will print it at 50 mm per second. Unlike a normal Ender 3 series or similar print profile where the wall and first layer are printed at half the speed when set to 50 mm per second, I will just set everything to 50 mm per second. The extruder and hot end of this machine can handle slightly faster PETG printing without any issues. Then, I will print this ABS crate. A regular printer with Cura will take over 9 hours, but with this Kobra 2 at 250 mm per second, it will take just 3.5 hours. In the first attempt, it failed. As an open frame printer, it's pretty challenging to print ABS without an enclosure, so I would try applying my favorite Elmer's Craft Bond extra strength glue. This time, the print finished in 3 hours and 21 minutes without any major bed adhesion issues. It did warp a little bit as the ABS shrank when it cooled down and the edges are not perfectly straight, but there are no layer separations. When compared to the 9-hour print done at 50 mm per second, the layers and edges of the slow print look much better, but the stringing is actually better on this 3-hour and 21-minute print. Next, I will print some TPU. I decided to print a cable clip for some under-the-table cable management using ARRI1 TPU. For a regular printer, it will take 43 minutes when printing at 50 mm per second. I will also use 50 millimeters per second on this Kobra 2, but I will set it to print at this speed for everything, just like how I printed the PETG trash can. The print finished in exactly 24 minutes, and it looks pretty nice. The cable clip can open and close as expected. I'm not sure if using TPU is the best idea for this cable clip, so I will also try to print it with nylon. The maximum nozzle temperature of this printer is only 260 degrees Celsius, but it should be good enough to print nylon. My first attempt was not good, as the nylon filament was moist. I will use the fixed dry filament dryer to dry it for 4 hours at 70 degrees Celsius. This is the second time I'm using this machine, and I didn't check the actual temperature last time. But this time, when I tried to put another thermometer inside to compare, I found that the dryer temperature cannot actually reach 70 degrees Celsius, and it stays below 48 degrees Celsius most of the time. When I tried to print it after drying the filament for 4 hours, I didn't see any significant improvements. So I dried it for another 12 hours and reprinted the same model the next day. It looks better, but the filament still wasn't completely dried, so I'd say this printer can print nylon, but the filament dryer didn't do a good job. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The extruder and hot end combination perform very well together and can efficiently melt filament at a rapid pace. It can print at 250 millimeters per second effortlessly on smaller models. 2. The motion system works well. For other bed slingers, when I try printing at high speeds, regardless of the print quality, the rubber wheels start to wear out before I even complete the review video. However, these steel wheels should be pretty durable and require much less maintenance. The more powerful NEMA 17 48mm stepper motor on the Y-axis also helps to move the bed faster without skipping. 3. The cooling system uses a 50-20 blower, which offers double the airflow rate compared to a 50-15 blower. This makes it significantly stronger than the stock fans found on most other printers, particularly those attached to the print head. As a result, it provides awesome cooling even when printing at high speeds. 4. The auto tool height sensor works very well. I didn't need to manually adjust the Z offset using a paper throughout the entire testing process. Since there are no manual leveling knobs under the bed, the inductive sensor, which probes 25 points on the bed, also worked well. As a result, I was able to achieve consistently good outcomes for the entire first layer of my prints, and I could print this single layered flat sheet of PLA perfectly. And as you can see, the result is great. Now for the cons. 1. The nozzle wiping silicone block is a nice feature, but it's only used during auto leveling. It would be better if the print had wiped off any filament residue on the silicone block before starting every print, and also check the Z offset again using the sensor at the back. When you print something at a high temperature, like 260 degrees Celsius, the nozzle may experience slight expansion, which potentially affects the accuracy of the preset Z offset. Considering that the necessary hardware is already in place, it would be better to just make more effective use of it. 2. The included slicer profile is only meant for printing PLA at 150 millimeters per second, which is not a major issue as creating your own profile isn't too difficult. However, this could be confusing for someone new to 3D printing. But on that note, I have shared my profiles for printing various materials at different speeds under the video description. 3. The hot end is functioning quite well, and it features a volcano-sized heated block. At first glance, the nozzle appears to just be a standard volcano nozzle. However, upon closer inspection, I noticed that the part that makes contact with the heat break has a smaller diameter. As a result, despite having the same threads and length as a standard volcano nozzle, it won't work. If you try to screw a standard volcano nozzle onto the heated block, it'll just leave a gap between the heat break and the nozzle. In my opinion, it would be preferable if the printer used standard volcano nozzles, as they are inexpensive and easy to get. In addition, the maximum temperature of the hot end is limited to 260 degrees Celsius. It would be more beneficial to have the option to upgrade to a high temperature hot end capable of printing a wider range of filament types. 4. Being a fast printing machine running Marlin, it would be nice to enable the input shaper feature, which has been available in the latest version 2.1.2 of Marlin. I reached out to AnyCubic about this, and they told me that they are currently working on it and plan to release the new firmware in the near future. However, it would have been ideal if they had implemented this feature from the moment the machine was launched, but regardless, I am looking forward to this update because this printer already produces pretty good prints when printing fast, and with the addition of Input Shaper, the print quality can be expected to further improve. In conclusion, priced at around $280, this printer has proven to be excellent. The hardware is of high quality, and the overall build is solid. I will be updating my website auroratechchannel.com and award this AnyCubic Kobra 2 the title of the best performing budget duty printer. This is because no other bedslinger under $300 offers a superior combination of extruder, hot end, and part cooling, which are all essential for achieving fast printing speeds. While it may face challenges in keeping up with the 250 mm per second speed and the 2,500 to 3,000 acceleration when printing larger models, it still outperforms every single competitor at its price point. Moreover, the inclusion of steel wheels, a stronger Y-stepper motor, and an AutoZ offset tool height sensor further enhance its value. Overall, I'm very impressed with AnyCubic's ability to integrate all of these hardware components into an affordable package. If you are interested in this machine, I put the link under the description. That's all I wanted to share about this machine. If you found this video helpful, please consider giving it a like and subscribing to our channel. Thank you for watching, and I will see you next time.